In this video, we're going to look at slope, and slope can have several different definitions. When we're looking at a graph or counting the slope out, we call it the rise over the run, where the rise refers to the y values and the run refers to the x values. Mathematically, if we want to find the slope between two different given points, we say that it is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, where the subs refer to subscripts, and both of these are y values, but you know we're dealing with the second point and the first point. Later on in your mathematics career, you're going to see a notation that says delta y divided by delta x. That is the Greek letter capital D for delta, and in mathematics it refers to a change. So this is a change in y values, which is what the rise is, divided by the change in x values, which is what a run is. Now I've taken the liberty of already identifying 2 points on each of these graphs. I normally leave them blank in your notes so that in a classroom I can make up the problem on the go. If I want to find the slope and I've got the graph in front of me, I usually want to start at the leftmost point and count the rise and run. Here we're actually going down, so there's a rise of -3 and a run of 1. So the slope would be -3 over 1. And I would prefer to write that as -3, although slope is the one place where sometimes it's okay to use a 1 in the denominator to denote the run. In this second problem, I'm starting at the leftmost point, and then I'm going to rise, going upward, and then running. I'm going up 1 and over 6, so the slope here is 1 over 6. And we use the letter m, I think that goes without saying here, to represent the slope. You also want to be able to find the slope between two given points. Now you do have the option of graphing these, or you can go straight to your slope formula. And I highly recommend that you keep writing this formula over and over and over again so that you memorize this formula. We're taking the second y minus the first y, that would be 1 minus 3 in the numerator, divided by the second x minus the first x, which would be 4 minus a -2. Now it's important that both of your subtractions go in the same order, and that's why I'm saying second point minus first point. You could go from the first point to the second point as long as you do the same in both the numerator and the denominator, but generally this is the way we do it, from the second point to the first point. So subtracting in the numerator, we get -2. Down below we get 6, and we always reduce our slopes, so we have -1/3 in this case. In the next problem, I'm going to again rewrite this slope formula, because the more often I write it, the better I'm going to get at memorizing it. And the second y is -3 minus the first y, which is 5, divided by 11 minus 4. So we will have -8 divided by 7 as the slope between those 2 points. Let's highlight these given points here. We have -3, -1, and 2, +1. And if I want to find the slope, I'm going to rise 2 and run 5. So the slope here is 2/5. If you are given a graph and you don't have the points identified for you, you need to look at where a graph will cross through these nice neat lattice points to identify a couple points on your own through which you can count the rise and the run. Here are a couple of sentences that you need to memorize. Parallel lines have the same slope, and the slopes of perpendicular lines are negative reciprocals, or some people say opposite reciprocals of each other. It's not enough to say opposites, you need the opposite and the reciprocal. For example, if a slope m, which I'll call m1, is equal to 2/3, M2, which will be perpendicular to it, would be -3/2. Notice I've changed the sign and I've flipped the fraction over. It is also a property of perpendicular slopes that their product is -1. Notice if I multiply 2/3 times -3/2, the 3's cancel, the 2's cancel, and you are left with -1. So that is another way to test for perpendicular slopes. Now we are given two lines described not in a graph form, but as two sets of points here, and we want to determine whether the lines through each pair of points are parallel, perpendicular, or neither. We want to start with the slope formula. So for line 1, I'll call this M1 will be y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And subtracting, I'm going to have 2 minus a -5 divided by -1 minus a -3. We get 7 in the numerator because whenever we subtract a negative we add, and in the denominator we have -1 plus 3, which is 2. And so the slope of the first line is 7/2. The second slope, which I will denote with M2, again I'm going to rewrite this formula. Personally, I don't need to, and you can wean yourself of that if you want to, but it's good while you're getting used to this. Subtract y's, 2 minus 4, subtract x's, 7 minus 0. We are going to have -2 over 7. Now, I'm looking at these. Yes, they are opposite in sign. Yes, they are reciprocals of each other. Therefore, I can say that these two lines are perpendicular to each other. And you can graph them if you want to verify that they form this right angle, or you can just leave it right there.